Hello everybody. The second experiment is something related to the data type in C. So here, as you know, there are different data types. So what is a data type? Data type, it can handle a specific range of values that it can store, which are determined by the number of bytes it occupies, and it indicates whether it is signed or unsigned. So the range of this data type, it depends on the system architecture and the compiler. It can be of 32-bit or it can be of 64-bit. So here when you look into this data type, there can be of a primary data type, derived data type, void data type, which can uh, include the different modifiers also. So when you look into this primary data type, you have the different types like character. This character is of 1 byte size. So 1 byte is 2 power 8. So if it is a signed character, the ranges between -128 to 127. But if it is an unsigned character, it starts from 0 to 255. So we do have the short int. The size of this short is 2 bytes. So 2 power 16. If it is signed, it takes negative as well as the positive values. Otherwise, in the case of unsigned data type, it takes the values from 0 to 65,535. And if the data type is an integer data type, the size of handling is near to 4 bytes, and 8 into 4, 32, 2 power 32. In the signed range, you have the negative as well as the positive values, and if it is an unsigned, you have the range from 0 to that specific value. And if it is long int, the byte size, it can be 4 or 18. It depends on the system architecture. Here also we can have the signed as well as unsigned values. And if it is long type, the byte size is a huge byte size. It is of 8 bytes. And here also we can have the signed as well as unsigned values. And coming to the float size is 4 bytes. And here you can look into the range. Here in the case of float, the precision value, it goes up to 6 digits. And if it is a double, the byte size is 8 bytes, and the precision, it goes up to 15 decimal places. And if it is a long double, the size, it can be of 10, 12 or 16 bytes depending on the architecture. And obviously this long double is larger than the double data type, and you can have the higher precision value. And here we do have the void data type that represents no value or no type, that is used for functions that return nothing. And we do have the derived data type. So pointers, what do you mean by pointer? It stores the address of another variable. And here we have an array concept. What is an array? It is a collection of elements of the same type data, same type. So the matrix and all, we use it with array. The structure and union, as of now, we don't have in your course. And then we have the enumeration derived data type. It is a user-defined data type which consists of integral constant. And we do have the modifiers to adjust the range of primary data type. They are like signed, that means it includes the positive as well as the negative values. Unsigned means it has only the positive values. And if it is a short modifier, it reduces the size, and if it is a long modifier, it increases the size. So when here is a simple program using this double. I'll try to explain each line in a detailed way. So the purpose of using this hash include stdio.h is to include external files into your program. So here the external file is stdio.h, which stands for standard input and output. This file is part of the C standard library, and it contains function prototypes and definitions for input and output operations. Why we should include stdio.h? Without including this header file, the program will not be able to use functions like printer to output data to the console. So that is the way we get access to the basic input and output functionality in C. So this stdio.h, it stands for standard input output, and it contains definition of functions like printf, that is used for printing data, scanf, that is used for reading input from the user. Apart from this, we do have getChar, putChar, fopen. And coming to the second line, int main, this is the declaration of the main function, which is the entry point of any program. The program, it always start executing from this function. This int before this main that specify the function will return an integer value. So this is the convention in C, indicating that the function returns an exit status to the operating system. A return of 0 typically indicates successful execution of the program, while a non-zero value, it indicates an error. So why are we using this main here? Main, it is a special function because it is a starting point for the program execution. It is where the operating system gives control to the program, no matter how many other functions are there. And the actual program starts with this main line. So here in this example, you have the double number is equal to 20.63. This line, it declares a variable named num, which is of type double. The double data type is used to store floating point numbers, that means decimal points. It can store large numbers with greater precision than the float data type. So why are we using double? The precision is more than float, and if you need more accuracy in calculations where decimal points are involved, it is better to use this double data type. Here in this case, the number is initialized with the 20.63. Random number I have used here. You can use any number. It is a floating number. So the variable name is num here. It stores the value 20.63. This value, it can be used in the program for calculations, comparisons, or printing. And then the next line we have the print within this codes lf comma num. So this line, it calls the print function, which is used to output the data to the console. It prints the value of num variable as 20.63 using a specific format. So the format specifier which is used here is percentage %lf. So here this format, it tells the function how to display different types of data. So this LF is used to display a double value. It tells printf to expect a double variable and to print it with a standard floating representation. So here by default this printf prints the double values with 6 digit after the decimal point. Here you can see in the output. So the print function, it uses the format specifier %lf to print the decimal 6 digit decimal output. So if you want to control the number of decimal places, you can keep on using 0.2 lf or 0.3 lf. That means only those 2 or 3 digits will be displayed in the output. So what is the reason we are using return 0? This is the end of the main function, and this will return a value to the operating system. When the main function finishes execution, the return value indicates the status of the program. So returning 0 is the convention. That means the program executed successfully without error. In C, a return value of C from the main function generally indicates that the program is without error. If the program is encountering an error, a non-zero code like 1, it will be sent to the operating system that indicates the error. So similarly, for the next data type, a simple program is given. Here you can see the input values are given as a positive, negative, unsigned value, long, integer, and the output is displayed for all this integer data type. And here you can see the output as a character. So the declarations are made as character. The variable name is my letter, and within a single quotes, you have to use this character. Rest of the lines are default lines from the pre-directive to the main and with the return with the open and the close braces. And here is a simple example for this float data type. So in this case, the float data type is used with a variable name as my float num is equal to 7.5. And here you can see the usage of the format identifier LF with the different digit values like 0.1f, 0.2f, 0.4f. That means the output, the value will be displayed with that specific digits. So that is going to be your second experiment which are related to the data type. Thank you.